Okay, so more of finding inverses today.
Oh, that's actually.
So first question. Finding inverse. What's our first step? Good. So we get y equals negative 5/4 x plus 3. So now we want to interchange the x and y. That's what it means when we're finding the inverse. So negative 5/4 y plus 3. And then what would our next step be?
-3.
Good. So we get x minus 3 is negative 5/4 y. What would our next step be then? Here, so we can do it in 2 steps or we can do it in 1. Do you know a way to do it in 1 step? And that's okay. Multiply by 4 and then you can divide by -5. That works. Or multiply by the reciprocal, negative 4/5. Either way is fine. So we're going to distribute here, and we get negative 4/5 x minus, and we have a negative 3 times negative 4/5. So I'm doing that over on the side. So I just multiply straight across, and I get positive 12 over 5. So it's plus 12 over 5 equals the negative 5/4 and the negative 4/5 cancel, right? Negative 5 cancels with the 5 and negative 4 cancels with the 4. And that's why we multiplied it by the reciprocal. So that's equal to y. So we want to use our inverse notation. F inverse of x is negative 4/5 x plus 12 over 5. Okay. Pardon? Absolutely. Okay, so number 2. What do we do first on number 2? We need to change g of x to y. So 4 over x minus 2 plus 1. So this one's going to have a little bit of a twist. You haven't seen one like this. So your next step is to...
Place the y and x.
Yes, we want to switch that x and y. So we have x equals 4 over y minus 2 plus 1. And so now we want to solve for y. So what would we do next, Susie? Minus 1 from both sides. Good. So we get x minus 1 equals 4 over y minus 2. So this is one of the tricky steps on this one. This is the first time we've seen one where that variable's on the bottom. We don't want it in the denominator. How do we get it out of the denominator? Yeah, we're going to multiply both sides by that whole denominator, y minus 2. So over here we get y minus 2 times x minus 1, and then these cancel and give us 4. Follow me so far? Okay, so we don't want to multiply out. The problem with multiplying out is we would get 2 terms and have a y in there. We need to solve for the y. So we need to get that x minus 1 over to the other side. How can we do that? Divide by x minus 1. And then these cancel, and we get y minus 2 equals 4 over x minus 1. And we have one more step. Add 2 to both sides. That's right. So add 2, and we get y equals 4 over x minus 1 plus 2. And then just write it in inverse notation. So now I want you to do the U try.
Oh, why did you say that? That's what I said. This is divided. Divide. Two fingers divide. But then switch it to the X. So that's the one.
From his wrist. Wow.
Derek, what do you do? 3 over 2. You said that your mom. You said she liked it.
Yeah, she was, I think.
Oh, I love you. I wasn't in that class. Yeah, get my dad. Yeah, it's all that you
I love when people say that no, like when I asked his name once and I thought about it and no one ever no one's ever called me like I don't know.
Oh, you mean like 2? Oh, I just made the mistake because I thought that means it was 2. But then I was like,
Good catch.
It's not their favorite though.
I just don't like how they're like a firm, like
Wait a second. Okay, I showed how to do it up there. There's the answer. Y equals, or F inverse of X equals 2 over X plus 3. Okay, last one. This one's going to be a little hard. I'm challenging you on this one. On these last two. So stick with me.
It sounds good to me.
Okay, mention back up here, please. Take those in there sitting quietly. So, we want to know if these functions are inverses of one another. What we could do is we could find the inverse of each one. We have to do it on both of them, not just one of them. We don't want to do that. There's actually a way to do it with just one step. So the way to do it with one step is to use composition functions. That's from last semester. Do you guys want me to double the homework assignment?
We should do individual notes.
So we're going to do a composition function. Remember that from last semester? So it's actually kind of cool math, but it is a little complicated. So if we do the composition function and we get back to our variable just plain x, if our answer is x, then that means that they are inverses of each other. Okay, because you're undoing everything that was done on the other one and you get back to x. So when we do this, remember we start from the inside out. So we're going to take our g of x function and we're going to put this into our x. So we're going to take this function here, the negative 5/3, and we're going to put the negative 1 minus 3/5 x inside, replacing it with the x. So to simplify that, now I have to distribute that negative 5/3. Negative 5/3 times negative 1 is positive 5/3, right? When I take the negative 5/3 and multiply it by the negative 3/5, what's negative 5/3 times negative 3/5? Just one. They're reciprocals of one another, aren't they? I'm not sure why you needed to turn around and make a comment about that.
That was a great answer. Dawson was smart. That's how we did it all.
So these, when we multiply them, they cancel each other out. I'll do it over here on the side. 5s cancel and the 3s cancel. So that just gives us an x. So we get 5/3 for this, and then we get x plus x for that part. And then we minus a 5/3. Well, what's 5/3 minus 5/3? 0. So then this just gives us x. So that means that, yes, these two functions are inverses. Yes, only to get just x. If your variable's in there, the x, that's here.
Another one with so long.
We're doing something that we did from last semester. We took this here and we put it in like. Okay, hang in there. One more. Okay, last one, f composed of g of x. So we're going to take our g of x function on the inside, and we're going to put that into our x in the other equation. You guys are almost there, almost close. You're really close to me not doubling it. So then we're going to get inside here, that f is now going to be cube root of x plus 2. All I did was replace this x with this. Then I have to minus a 2, cube it, and then minus 2. Okay, so again, I replaced this x with this here. And I go inside out. So plus 2 minus 2 cancels, right, to 0? So this gives me the cube root of x cubed. What's the cube root of x cubed? X. So I get x minus 2, not quite x, is it? So my answer is a no. So yes, those will be challenging.